So, over here, we're going to go to my colleague who's from the BBC in the UK, Ian Wagton, who's the Senior Technology Transfer Manager with BBC R&D. Hey, Ian.
Hey, good to see you, Mark.
Good to see you. So you're going to talk us through this extraordinary piece of kit here, which is a 5G network in a box.
Yeah, these are kind of quite key to our user case, really. When people think about 5G networks, they tend to think about the kind of large-scale networks that the mobile network operators provide. But we kind of quite early on thought, well, what if we could provision these types of networks in TV studios and OBs outside broadcast? We could start to kind of use this technology in a slightly different way. So we've been working for quite a while with both standards and implementation to kind of look at it. And essentially what we've got here is a 5G core that's running on commodity hardware. It's an Intel i9 PC. Underneath that, we've got a radio head, which is the sort of radio amplifier. And then that comes out and it's going up to here, which is the antenna. It's a 2x2 MIMO antenna. So that's the heart of the system.
So this gives you a lot more flexibility, a lot more agility and ability to be creative in productions.
Yeah, I mean, we've been using mobile technologies for a while, 3G, 4G bonded technologies, and they've really revolutionised what we've done with our news gathering and our contribution workflows. But production is slightly different because actually we need to make sure that we've got reliability and we've got robustness. And while the bonded cellular units work on the public networks, what happens is that they'll work in the morning, and then somewhere like Tivoli here with the Tour de France, 50,000 people will turn up later and they'll all be uploading their content on the networks, and sometimes that can drown out our signals. So we've really been looking at solutions that can work alongside those types of deployments.
That's one of the benefits is the quality of that guaranteed quality of service.
I mean, absolutely. We can guarantee 300 megabits per second uplink on this on this unit, and that gives us lots of bandwidth. It's very secure for us, and we can start to split different types of signals up and prioritise them depending on how we want to do. And the other really important thing is that we can change, because of the spectrum we're using, we can change the time slots of the transmission so that we can get more uplink out of the solution. So here we've actually tuned it so we've got sort of quite a bit more uplink, and the only reason we can do that is because we can get access to spectrum that's slightly outside the normal spectrum.
And that's really a really critical piece.
Yeah.
That in the future, the access to shared spectrum is going to be...
For us, actually, the technology's great, but it only works if we've got the regulation and if we've got the kind of commercial models that sit around that, and those are key to us, because actually we use spectrum in a kind of quite a strange way. We'll rock up somewhere like here and we'll use it for 2 days and then we don't need it anymore. Where quite often the licensing models are built around, you know, hospitals or factories where you build something and it lives there for 5 years.
Right. So that's the foundation.